now we have Loay from Environmental Engineering.
All right, so no matter who you are, what you do, or where you're from, you have one thing in common with everybody in this room. You need oxygen to survive. Now, contrary to popular belief, most of our oxygen does not come from the rainforests or even trees in general, but instead it comes from the oceans. The map behind me is a composite satellite image showing that 70% of our planet is covered in oceans. It also shows that there's something very exciting happening on the surface of these oceans. The different colors represent the different types or species of a microscopic group of plants known as phytoplankton. These inhabit virtually every region of the globe, from the cold Arctic to warm tropical waters. The tiny plants take in carbon dioxide from the atmosphere and sunlight and release massive amounts of oxygen and organic compounds in return. The organic compounds are believed to cause a cloud formation and play a critical role in climate regulation. And you only need to hold your breath for a couple of minutes to find out why oxygen is important. This balance of taking in carbon dioxide and releasing oxygen between the ocean and the atmosphere has existed for millions and millions of years. But unfortunately, we now have a problem. The rise in global temperatures is expected to cause a negative effect on phytoplankton. However, we're not really sure how, why, or for how long. My research will help answer these questions and perhaps propose some solutions. In a similar way of blowing into a breathalyzer to get your blood alcohol level, I'm collaborating with NASA to do a breathalyzer test on phytoplankton. My research is based on a small island called Sable Island. Some of you may know it because of its wild horses. It's located just east of Nova Scotia. Twice a year, phytoplankton populations grow rapidly around this island, creating a phenomenon known as a bloom. This bloom is conveniently visible from space, so I just piggyback on NASA satellites and look down to see when the blooms are happening. And when I know that, I fly to the island, land on the beach, and collect a lot of air. Then I bring the air samples back to my lab and analyze them to see what's actually in that air. So far, I've seen spikes in organic compounds corresponding to periods when these plants are most active. This is really exciting, or at least it is for me. Why? Because I can dig deeper and find out what those spikes are made of and make inferences about phytoplankton health and how global warming is affecting their well-being. The research I do and the people in my field do will make sure that you have oxygen in your lungs for a very, very long time. Thank you.